So another parameter of interest usually when in the investigational era, when actually cath lab and all in the experimental laboratory, when they were doing in a particular muscle, it was like the dp by dt was having a huge effect. That is, dp is the difference in pressure which is varying on the variable, the pressure which is varying when traced over a time. What is the time taken for this much of pressure to vary? That's what is actually the dp by dt. When assessed by echo, it is the patient's one of the most important requisite is there should be some trace of mitral regurgitation jet should be there, and important thing is that it is afterload and preload independent. So if there is a slight MR jet is there, you put the color Doppler continuous wave Doppler on it, and you will get a graph like this. Okay, you will get a graph like this. You can show here also, it is inverted graph. So you will get a graph like this. Okay, this is inverted graph. This is TE, that's why it's coming like this. But anyways, we can see here. So if the graph comes like this, you measure the gradient like here. If you can see 1, 2 and 3, so you can take it as a pressure gradient at 1 and pressure gradient at 3 meter per second. What is the time taken for that? That is the difference in time and difference in pressure. So here we are calculating difference in pressure is we determined, it is predetermined. Difference in pressure is predetermined, 1 meter per second and 3 meter per second. So when you calculate it, LV dp by dt 4 into 3 and this one, that is 36 minus 4 millimeter of mercury, that is 32. It I am wrong. So 36 minus 4 is 32 into 1000. So 32,000 by difference in the time, that is what is dp by dt. So when you are measuring the time interval, that is the difference between this difference, that is 1 meter per second to 3 meter per second. That means if the LV is pumping very fast, very vigorous, if pumping LV function is very good, then the time taken will be very less. So the difference will be the division will be from being a lesser, like 1 second, 2 seconds, and it becomes most probably the 18,000. Okay, so 3 seconds it becomes lesser, like 12. If 4 seconds it becomes 9. So as the time taken for the regurgitation increases, it means that the patient is having LV systolic dysfunction. In that way, we can categorize that if it is normal, where the time taken is very much less than the 27 millisecond, then it is most probably the dt by dt is more than 1200 and it is normal. If it is very less than 500, then it is most probably severely reduced, because the time taken for dt, the time taken from 1 meter per second to 3 meter per second is most probably more than 32 milliseconds, where the LV is having globally dysfunction.